Alright, so this is the lecture 10, I believe. So we're going to talk about collision on this one. A few people request collision, how to do the collision and all that. They're stuck with that in the midterm. So anyway, not all the people need collision for the midterm. So some of them need it. So anyway, I'm going to cover that lecture. uh, but I'm expecting you not to copy this for your midterm. Just get the idea and write your own code. I don't like to see my code in there for your collision because that is not good. So just see how I'm generating this and then come up with your own code is better than just copying mine. Okay, right. So okay, so let's start the lecture. This is a lesson 10, I believe. So new project, and we call this one lesson 10. So I call it lesson 10 here. Lesson 10. That's what I'm going to do. And so next, yeah, the same thing that I used to do before, right? So this is the same ritual, right? And then okay, so that is my project, and I go here and create a new class for this one. So the new class, and I call this class underscore check collision, right? Collision. And right, so that is my class I'm going to create, right? Okay, so I have that, all the things I needed here, and then I had to add my previous class and then move on from there. So I go this is my what I'm working on. So I get, I think, lesson 9, and then I'm going to copy my include and source, and then my images and the main, all that I'm going to copy from there, and then I'm going to go back to my lesson 10, which is I just created. So right here, and then I'm going to paste it right here. So to last, do you want to replace? Yes, please go ahead. And then I have all that here. And alright, so the next settings I have to do is go and add these files into my project. So go ahead and add those files. I have all the CPPs here. I think I have some extra unnecessary ones. So this one, yeah, I think I need all. Right, this, yes. So let's go ahead and add those things. There you go. So I add that, and then I'm going to my includes. Go ahead and add all. So I have that set up. So now I have all the files here, and then one more thing I need is I go to the project properties and build properties on this, and the linker settings, I need my soil in there. So I'm doing the same thing just to make sure everybody understand this. I encourage you to do the same so you get a little practice on setting paths on IDE. It is not related to our project, but anyway, so when you're mastering one IDE, that's good enough. So this is one of them, right? Okay, so I have all that, and then let me compile, see whether right, it compiles without any errors. Right, sounds good so far. Right. Okay, so let's run this and see what I get. right? So I have enemies, and then this is what I have, right? And we're going to start from there and apply some collisions whenever this player hits. Let's make them move. So that will be the project that we're going to do today, right? And I'll go through some techniques. What are the collision types, and how we're going to do that. So I will give you a little brief explanation on those. Uh, yeah, so that is the lesson I'm going to cover today. Okay. Alright, so let's check what are the collision types that we're going to address here, and how we're going to maintain those. A few of them we're going to implement, not all of it, but I'll go through most of it, the theory behind it. Okay, so saying that, let's create a few of the classes, the functions that we're going to use. Anyway, I had to return boolean value. The first thing, let's call something like is linear collision. Yeah, it's a linear collision. I'll talk about what it is in a minute. So this is a one type of collision. So you can put all the collisions here and implement that if it is necessary for your program, right? So this is one of them. What are the parameters you need for linear collision? Maybe either x or y. Let's have two floats in this case, float 1 and float 2, right? And then another one which we can do is a radius collision. So it is radius, so that is, let's call it radial. It's radial collision. Okay, and I'm just coming up with names. It's not so in this case we need a y position, x position of the player and the enemy, and also we need the radius values that we're going to set up the boundary. In that case we need 6 floats. Well, I like to address one more thing here. What is the advantage if we use a structure, a type def structure, to define x and y instead of we just having the position defined as 2 variables? So the advantages and disadvantages on that, I'll show you here after I type this. So I need one more, right? Yes, I need one more for this. Okay, right. So what else? We need I'm going to talk about these two, basically the linear and the radial. Other than that, there are so many other things, like you can apply some checking on the boundaries. So it's a wall versus the position. In that case, let's say you check with either hitting on the floor or on the walls. In that case, is collision flow, we can say, right? Collision with flow, right? So, or walls, in that case you can have something like that. You can check on those. So that means a collision with environment, right? So that is what it is, collision with the environment, right? And also ray versus is a collision with a circle and a ray, right? So you can say circle ray collision. So I will describe what are these in a minute. Okay, so that is one more. In that case we need xy position of the player, or whatever the ray is coming from. So you need that, and and then you need the position of your the other object, whatever it is that you're going to plan on having. And yeah, that's pretty much will do. And the radius, yes. Okay, so that is one more thing. And if you're thinking of building something semi 3D, there's something called Boolean is cubic collisions. Yeah, it's a cubic collision, so that is another one. So in this case you have to give your position of your objects again, right? And then you assume they're in a cube and you test whether those are collide each other, not. So you need 4 floats in that one. And then there's another one, sphere collision. So it's a sphere collision. I'm not going to implement these, but I will explain what these are, so you can if you're really interested, you can implement just following the guidelines I'm just going to point out. Okay, so these are mostly for the 3D, and also you can use these for the partial collisions that you want to get the precise collisions. This will be important. Okay, so there are 6 here. Let me move this guy to the bottom because the collision with the floor or the walls. The others are very these 3 are very important when you're thinking of 3D, right? These 3 right here. And for the 2D, I think this is enough for us to do this gaming. And if you want additional ones like collision with the floor, walls and things like that, if you want to implement something, you can. So I will explain these. So I need only 3 floats in this one. So if you are interested, you can go through the description I'm going to give you, and then write a code just the way I'm going to guide you. Okay, right, so this is these are the float types that we're going to talk about. So yeah, so let's save this and go to the CPP part of this, which is the implementation. When I go there, I will discuss each of them. So what are those are and why we having so many kind of collisions. Okay, right, so these are the collision types. So let me describe each of them. Okay, so one of the things I was talking about is the data structure, right? I said, well, it might be easy if we using different data structure than what we are proposing here, right? So let me talk about that first. Okay, one thing I want to point out here is having a struct like this. So let's say I have type def, right, structure, like float x and the float y. Instead of I'm using x position, y position, let's say I have this, okay, and I call this a pos, right? And then after this I'm saying pos is my position, right? Position, or you define whatever it is. So in that case I don't need this many floats. These 2 I can replace by just a simply position here, right? And then when you access that, you can say position x dot x and the position dot y. So in that case, yeah, it's easy, much easier. Instead of you writing at 6 entries here, I can cut this down to 3 or 4, right? These two are 1, this is R1 and R2, of course. So this is the one advantage if you're using this kind of a thing for all your game, throughout the whole game, defining your float x and float y as positions. It will cut down this many variables into very short amount, right? So that is something that you may have to think of when you restructure your game. I'm just giving you the basic one, so that's why I have x pos y pos different separately, right? Okay. Oh, I stick with this because this is just a basic for you to understand, but it's better if you're using something look like this for all of things. It will make your life more easy when you pass through things. Okay, right, so that is one point that I have to point out here. So let me go through the rest, which is what are these collisions I'm talking about here, right? So yeah, this linear collision is nothing but, let's say I have one object here, right, and then here there's a bullet or something comes in, right? So I can draw a line here. Let's say I'm drawing a line, right, instead of a bullet. So let's say the enemies that I have, these kind of enemies, right? So I know this enemy is not flying up or down, so anyway he's going to cross this, right? Okay, so that's how I design in my one. So the linear collision works for me better. So if I get so anyway he's going on x direction, he's not going to fly, this guy is not going to fly. If you're flying or jumping over, yeah, this is not going to work for you. So in that case we will talk about this option, right? So in this option, what is this? Is nothing but I have x position here, right? So that is, let's say it is a player's x position. Either I can draw it here or here, whatever, if you cross the player. But anyway, if the player is doing action, let's make it like this. So in that case, only thing I have to do is check the distance between these two, right? Okay, this one and the line, of course. So from here to here, let's say, right? It's better if I explain this as, oh, let's get a better one that helps you much better. So let's redraw again. Okay, so what I'm going to do is I'm going to have my enemy, which is like this, and then I have my player like this. So let's have my player, a line on my player, which is going to be here, right? And then this is the x position, position of the line, which is x position L, right? Okay, and this is my enemy position, x pos E, right? Okay, since my player did not move or anything, he's standing in one place and hitting, only thing I have to consider is this distance, right? So if this distance is really small, like for example I can say here x position minus L position. If I want to talk about both players moving from enemies moving from this way or this way, I can have it something like this as well. That means I can have the absolute value of this, absolute value, right? And then I give a threshold. So whatever this value is called threshold, right? So that is a threshold. So I say less than, if you get the absolute value, if it is less than 0.2 or 3 or whatever, then it is a collision. If it is not, it's not a collision. Right, so that's a simple line. So I can write it something like this and return that. So I can take care of something like that. Okay, so that is very linear. check whether you want to get the collision between two objects. Okay, so only problem in this one, let's say, well, you are here and your player can jump over, right? Let's say this is your player jumping over. So in that case, of course, even he jumping over you, right, at this moment, that this one meets and it says true, because this exposition and this exposition at this moment, actually this is, I can call this P if you want. So in that case, well, even you jumping over, it is a collision. So this is not going to work for us because of that. Okay, then we'll look at this option. So this is another option, which is I can do the radius collision, which is I put my enemy into one circle and I put my player into another circle, right? So this boundary is defining by the R here and R here, right? R1 and R2. Okay, then what happened? Well, I know the distance position here, I know the distance position here. So what I have to calculate is this distance right here and check whether is it bigger than R1 plus R2 or not. So in that case, I can say square root, right, of well, the x pos squared of the enemy plus y pos squared of so this is x squared plus y squared of this distance from here to here. That's what I'm going to calculate here, right? So how do you calculate the distance? Is nothing but you get the distance of this guy minus this guy. So I'm sorry, here you have to say minus this is, let's say this is x pos of the enemy, say E, and this is P, right? So subtract those two plus, and then y pos E minus y pos P, and then the square of that, that is the distance between these two. And if this is less than R1 plus R2, yes, there's a collision. In this case it's a collision, otherwise no. So you can do like that as well. So what this means is you put them in a sphere like this, right, and see whether those are collide each other. So but the problem here again, it's not precise. If you have a long body with the short width, in that case, well, this one is violating so many things because there's so much empty space in between. But in 2D mostly this works. I'm going to use this one. No, I'm going to use this one, but you can use this one as well. This works too, especially when you're having these kind of situations. This helps a lot better than just the linear one, right? Okay, and then I'm talking about another one here, which is the circle ray collision. So this is like if you shoot a bullet or something like this, you can consider this as a ray or a smaller one. Ray collision with the spheres using for ray tracing, but in this case I can put my bigger object in so this is also check the collision with this one will check the collision with the rays, like just a line, whether he's in the right line or not, right? So what is the equation for a circle is, you say x squared plus y squared equal r squared. So that is what we call the equation of a circle. Okay, and then this is the radius, of course. And if you take a line Of course we know it is x squared, I mean x y equals mx plus c or v or whatever, b or whatever, right? So this is the equation of a line. I'm going to reintroduce this one. It's differently, especially in graphic class. I'm going to teach you vectors and all that, so it will be easy for understanding. But anyway, take this as a ground. I'm going to define this line using the x as initial x position, right? x0. You have to take two positions of x. So let's say defining this line as starting from x0 and x1, so that is the direction it's going. So in this case this will be equal to t as a counter, and it's going to be x1 minus x0, and the y part of that is going to be y0 plus t y1 minus y0. Okay, how did I get this? This is actually the parametric equation of a line. Okay, I'm not going to go through this one. This is a long lecture. How I'm going to get these two, I had to define, I had to introduce vectors and all that just to introduce this part. But take it as what is this t? Is t, you can define something which is if you take this one somewhere far away here, of course you define it between that, but you don't have to consider this in this case. If it is t is greater than 1, it will go all the way like that. So in that case let's take t is greater than or 0 or equal to 0. Okay, in this case what I'm going to do is I'm going to use this equation and this equation and apply that to here. So when you apply to this one, you know already r, the radius that you're going to give to your player, and it will give you the quadratic equation for a t, right, with the t value. Why? Because x squared means this whole thing squared here, y squared means the whole thing like this squared. So when you apply this one to this, it is just addition of these two will be equal to r squared, right? So it is a quadratic equation. So you don't have to solve this actually to figure out what's going on. You have to check. You can you just give this equation and you check whether is it going to intersect. So that's what I had to do. So in order to check that, if you have a quadratic equation, you know that b squared minus I think second minus 4ac square root. So I think it is minus b, yeah, it is minus b plus or minus square root of b minus 4 AC divided by 2a, I guess. That is the equation for quadratic a solution for the quadratic equations, right? So if I use that here, what I get is this 2a. So what I get is whether this is going to intersect or not. How do I check that? I can check that by this value right here. Okay, so what I have is simply b squared minus b squared plus or minus square root of for b squared minus 4ac divided by 2a, right? So consider this one right here. Okay, so I consider only this part. So if I have one value for this guy, the one value for this value right here, if it is equal to 0, that means I'm cancelling out this plus or minus part. So that means minus b squared over 2a. This is just a one value, right? Okay, I'm not, there's no b squared here, it's just b, right? Okay, so this is just a one value. So in that case, I know exactly this one will touch this one, right? So that is the one condition. So the other one is, this is a square root of some value. So in that case, if I have b minus 4ac is greater than 0. So if it is greater than 0, right, and that means I have two values, obviously. This one will have two values. Why? Because this is greater than 0 means it has exist already, and then I have two values, one for the plus, one for the minus. So that means this is the situation. So this is one we have to consider. There's a collision, right? If it is not, for example, on the other hand, if I have this one gives me a negative value, so that means this guy is giving me a negative value. So the negative square roots are not exist, right? You cannot have something like this. This is not imaginary numbers you have, but in the real maths that we do, we don't have that. So in this case, that means there's no collision. It's going like this. So only consider here is you have to check whether this guy is bigger or not. So if this is bigger than 0, yeah, so if this one is bigger than 0 right here, then we say there's a collision. So this is what the ray collision is all about. Okay, so that is a collision of a circle and ray, so we can use that as well. Okay, so these cubic, the cubic ones are not for this. It's called bounding box, obviously. There are something called bounding box collision check on 3D graphics a lot, more than anything else. So in this one, we put our objects into a cube like this. So your objects will be in the cube, and then there's another cube I can access and see whether these two are colliding each other. So how do I do that? Well, for the squares, for example, I can check with the two nested if loops. If this one and this one cross each other, right? So this is a situation when they are cross each other, right? So only thing you have to check is this boundary and this boundary. Right, so how do I know that? Well, if I know the x position, y position here, x position, y position here, only thing is I'm just adding some value to here to make a box. So it is x pos, right, plus 0.5, right? So this is the boundary for that, and then this boundary is maybe x pos player minus 0.5, right? So whatever the value it's given to this one and this one, if these two values if it is colliding, you can check that, or you can subtract these two and get the threshold, just like the first one I was talking about. So that will tell you whether these two are cross, and then if these two are cross, you have to check whether these two are cross or not, right? So in that case, if this is the situation, right, so you have to check whether it's crossing these two, right? So it is the y threshold, and then if both satisfied, that means there's a collision, otherwise it's not. So this is the collision you check for the cubic. So you may have to consider your z-axis as well if it's a cube, so that's called bounding box. Okay, so this is if this satisfies, and then if it is a z, of course the z position also you have to consider, so you check the z positions as well, and then you see whether that happens. So in that case it will be cubic. So there's a lot of checks that you have to do, the if statements, nest of if statements on that, right? So that is what we call the cubic. I'm not going to implement this, but you can, by the idea I gave you. so it will be easy for you, right? And yeah, there's another one which is called cubic tree. This is a one check with a one box, or you can create a model. This is if you have a 3D model like this, right? I can put one box into his head, I can put another box into his body, arms, like that, another box here, and another box. So he's covered with boxes. So in that case, you can check the cubic with another model, or whatever you do. You use the same, but this time you will make the tree of boxes. So it is one box, and then it is the structure of this, like the box boundaries, and check whether it's collide inside this. So this is called tree, the cube tree, or it's a tree kind of a structure, and then you check whether it's colliding each other. So this is the advance of this, right? So I did not implement anything for that function. You can that is pretty interesting way of doing this. Okay, the other one is called right here, the sphere collision. So let's look at that one. That is also a pretty interesting one. Alright, so in this case what you do is actually you get okay, so the very basic one is the circle thing that I was talking about. In this case we are talking about spheres, so in that case you will have this depth as well. So spherical sphere collision is nothing but sphere to sphere. Instead of x, y only, now you have z squared as well as the distance. So this is the square of this is the distance from, so if you subtract these values from this one, so it is like actually it is like this: square root of x minus x1 squared plus y1 minus y2 squared plus z1 minus z2 squared. So that is the actual distance of this one to this one. Now you have 3D, right? So there's a depth on that too. And then you check that with r1 plus r2, which is the distance of this radius. So that is also for the 3D that you can do that. Okay, so and the advance of this is if you have one model here, right, and you can put this one in first one is a big sphere, and then you subdivide that sphere to smaller spheres like this, right? So smaller spheres like that. So if it is collide with this, then you check is it going to collide inside. So first one, if you first test true, and then it come to the inside test, and then you check whether this sphere is correct, is that it's going to collide to this or whatever, then it will go inside like that. So it is precise. You can get the precise collision in that case. If you have your object here, which part of your object is going to hit, you can subdivide your spheres and then calculate that. So this is a sphere tree collision. You call it sphere tree collision, right? So you can use that. What is the advantage? Yeah, you have a simplified test check here, right? And then you can go through that. So those kind of things are also helpful for the 3D more than 2D. So that is this one. Okay, and then the floor with an object, of course I can have the floor, and then I have my object, the position of this, if this distance right here between this one and this one, or you can just say the x position. If you only consider x position, whether is it going to cross this, that is similar to the linear, right? So but yeah, this will be helpful whether you have, if you have walls, whether check to that, either you will have x and y, maybe another float here, right? Another float here to test that. So I'm not going to implement these. You can work on these by your own, but I'm going to talk about radial collision and the other one is the linear collision, and we're going to implement those two and see whether that applies. So I just leave these as is. If you want to fill those, please feel free to do that, and I think I give you enough knowledge for you to do that. Okay, right, so let's go ahead and implement our first two on this, which is a linear collision and the other one, right? For the linear collision, in my case, I need only one, which is x positions. So let's have here x1 and x2. So I'm just writing it to suit my conditions here. Okay, so before I start, I will have to go and include math.h here. So I already have it. So if you don't, just include this math.h on the top. So you need that, right? And then we come here and we say if absolute value of so this is f abs obviously of x1, right, minus x2, so this will count into both sides, is less than 0.05. This is very close, right? Yeah, if that's satisfied, I'm going to return true, right? So if it is less than that, that means it's good, right? Else you don't have to say else, it's going to be anyway. If it is not satisfied, this is coming out, so return false. You don't need else in there. Return false, right? Okay, so if it is satisfied, it goes in and then satisfy this one and return, otherwise it will come here. So let's see if that works. Right, so it's good. So in this case, the radial collision, so if it is so what we're going to do here is we have to take two values, right? One is for x for the player, so let's get one for the enemies, x2 here, right, for the enemies, and well, let's take x1 and y1 for the first guy, and x2 and y2 for the second guy, and then the radius 1 and radius 2, right? R1 and R2. So those are the boundaries, right? Okay, and if those are satisfying each other, I think most of you guys should use this, because the reason for this is if you're having the wide objects that you're going to jump over or something, this will give you the collision signal earlier so you can take action, right? So it is best that using a radial collision than the other, right? Okay, so then I had to use the square root, sqrt, and what I'm going to use here as my square root is the subtraction, the power, yes, obviously power of 2. So the power of 2, what I'm going to the power up, so x1 minus x2, right? It doesn't matter what order, because I'm going to make it square, right? Plus again power of what? Power of y1 minus y2, so the comma 2 here, that is the square root of the value I'm going to get. So the square root of value come up to here, so that has to be greater than less than, right, r1 plus or 2. So if this is the case, I'm going to return true. Return true. Right? Okay. Otherwise, I return false. So that's good for that guy. Right. So those are the two things. Well, here, as I explained, you can write these things. I'm using only these two for this short lecture. So let's talk about these two. Okay. Let me make sure I write it right, and so I can compile and see whether I did it right. Yeah, so far so good. So I have this collision check right here. So this is what I'm going to use for my code. Okay, so where am I going to use this? Well, let's go and check with my enemy class. I had to add put some actions in order to make sure these are working. And then also I had to, when I'm going to check these when the keystroke, when my player is hitting, whether there's a collision or not. So where do I hit? Well, I think my actions of the player, I can do that in my scene. So let's go ahead and implement something on the scene, and the action whatever is going to be, we're going to apply to enemy. So okay, go to enemy class, and enemy CPP, and let me add something here for my actions. So I have only 2 actions. I'm going to get more actions now, right? So right, so what is the other action I'm going to do, right? So this will be when collision happens, what's going to happen. So it is case 2, right? And of course you need break. So what I'm going to do here is come down. I'm going to apply something here. So it will be the same code of previously drawing thing. The action we'll think about in a minute. So let me apply this right here. Okay, and the ticks will be the same. I'm going to stick with 1 frame, and this is the action. So there's no movement of animation. It's just a 1 frame, maybe the first frame I'm going to use. And yeah, in that case I don't need this line right here, because I'm not going to move the frames. It's going to be same frame. Okay, maybe I'll do the rotation. That's what I have here in the top. I have XYZ, maybe the Z rotation. When you hit something, I'm going to change this rotation. That's what I'm going to do. That will be fun to see whether he rotates, right? So let me get that and apply that into my code. Okay, so if he get hit, let's rotate them for now. Okay, so at least we know something. When you're rotating, let's rotate them in maybe in random rotation angle. So let's say float and rand. Yeah, so the rand function, right? And on the rand part, divided by maximum rand, so it is a float again. Oops, float, and let's get the max rand. This is something that we did last time, right? Yeah, rand max, yeah, and then it will limit our number to smaller number, and then I'm going to do is multiply this whole thing, right? So, oh yeah, this is extra. Oops. So what I'm going to do is That is too small. When you get this value, let's multiply that by 100. Let me check my brackets. This one is good, this one is not good. So alright, oops, this is good. Right, so now I have right brackets, yes. So I'm going to rotate him and then yeah, obviously I can move him, rotate him and move him. So yeah, let's do the moving as well. So X move, I can do, if you hit you go back, but so this is equal to, so I'm going to move him backward. So just float, and then again the same rand value. Yeah, so let's get this guy, and yeah, I'm going to use that. So I will have random speeds as well because there are multiple. Let's make it a little faster, like 50 here. Right, so yeah, he will move, he will rotate when it gets hit. So that is the action I'm going to apply when there's a collision, right? So that is, I apply that where? Well, in the enemies, and I'm going to apply this. So I need to draw enemies, drawing is already there. So it's good. So this is what I'm going to do, right? Okay, and right, so this is action. So only setting the actions here, that's all I did. Where I'm going to implement these actions is in my scene. So let's go ahead, and obviously we have to do the keystrokes. We'll check that in a minute. Next one, we'll go into the scene, and then we're going to implement this in the scene, right? Okay, so scene, let me go to scene, and this is my scene. The first thing is, yeah, I have to check the collision. So I will include and underscore check collision, and let's have a class here, right? Underscore check collision, and I call it hit, right? And then it's a new, right, new underscore check collision. It's a function, right? So that's what I'm going to use here. So that is, I can call anything which is hit, and then that will help me to make sure that whether I hit something or not. So yeah, so where am I going to do this? Well, I can do that in the draw scene because I'm calling actions in the draw scene. So I can apply this one before I do my actions. So let's go to the draw scene here. That is the only loop that I'm working on. So this is what it is. Here are the actions I'm calling. So what I'm going to do here is, before I do the actions, right here, right? Okay, so after you move the enemy, I'm going to check whether this one is going to hit or not. So that's what I'm going to do. Anyway, it's going to be in a for loop, so this is a good place to put this action test, right? Okay, so one more thing, you have to check action only when the player is hitting, right? When the player is hitting, that's when I'm going to check, because when the player hits, that is the collision I'm going to apply here. Okay, so the assume, otherwise you can pass the player walking. So that is only for this particular example that I'm going to give you. In your cases it will be different, so you may have to be creative on that. So let's do this. In this one player, so I'm going to check his action. So the player's action has to be, I think the hitting action is 1, right? So equals 1, right? And what else I have to check? The player's position. Why? Well, let's say he's hitting one direction right now. Okay, so this is my player position. One is, let me check in my inputs. I have two actions for the player for sure. So let me check one little thing here. Right here, let me see whether I have actions. Yeah, so this action is one is when I press in the left button, the other is right button. I want to make sure which one is left and which one is right. So the action 0 and action 1, and this is a key up action. So these are the two actions I'm doing. I know it is a case 0, so it is not the action 1. I'm going to do the case when I press the right button, the left button, left arrow key, that will be action 0, right? Yeah, so this is action 0, and for the action 0, what I have to do is make sure player is very close to me, or player is on my right side, I mean the left side. So make sure you do the action this, and my player has to be on my left side. So what I'm talking about here is, let me explain that before I write this. What I'm talking about here is, so in my case I have a player here, right? So this is my player, and the enemies are coming from this side, right? So the enemies are coming from this side. So I'm going to hitting this way with whatever I have. So then I have to check whether the collision. So then they will move this way. So I had to write when they're moving this way. I did not apply that yet. But I want to make sure this collision happens and check this one, right? The linear collision works for me. Why? Well, because right here, this one, it's just I don't have to jump up and down, so it is only the linear collision I can check here, so it will be help me, right? So let me do this with the linear collision, which is going to be pretty simple, right? Okay, so the simplest collision ever, right? So then I have to make sure the player's X position, right? Player's X position. Player's X position is down here, is less than enemies left position. So it is the square bracket, right? Because I have I in there, right? And dot X position, right? Dot X position. Okay, so this is the case I'm going to check. If this is satisfying this condition, so then I'm going to apply my collision. So it is if is linear collision, right? So it is, oops, hit here, hit HIT, this is the one, and the linear collision. So linear collision, I have to give two positions, right? So let me delete this one right here. And what are the two positions I'm going to give? Well, I'm going to give PLY X position, right? X position, and then I'm going to give my X position of the enemy. So it's the same thing here, which is I have already, right? So that's the same thing. So let me get that and then put it here. So okay, so this is the linear collision. If it is less than this, means already enemies on my left side and they're really close. Whether they're really close, I'm checking with this. So if it is really close, I'm going to set simply my action is going to be right now is dot action is going to be 3 or 2, right? 2, I guess. Yeah, 0 and 2. That's what I said, right? Let me check. Yeah, this is 2. Okay. Alright, so okay, so it's just simply checking the linear collision, and then if it is satisfied, well, I can say this is the case. So let me see what happens when I apply this into my code and then run this. I think that's all I need. Do I need more anything else? I don't think so. So let's see. Let's see what happens. Right. So I have no bugs. So it's running okay. Now if I hit, oops, they're disappearing. But that means what? My collision works, right? Oh, but they're disappeared in thin air. So I had to see what happens. But anyway, as far as I know, that works the collision, right? So, right. So the action has to, I had to address the action. But anyway, the good part is there's a collision and it's check and it's work for up to here, right? Okay, so that part is good. So I know it's going to hit and it's worked for that. Right, so let's go back and check what we can do here in order to handle this better. Why is he disappeared? Oh, I know. Well, I'm multiplying this by 50. It's not good. I need a very little movement. So let's have this one and see where the rotation works. I should work now. The rotation, multiplying by 50 is too much. So let's say, oh yeah, now it's rotating. Yeah. So, but they're moving to the same direction. So it's not good. So let me see what happens. I think I had to do negative on my movement, right? So let's have a negative value and see whether that works for me. Okay, so now if I hit, yeah, it's going there that way, and they're rotating and then going and then coming back. Right, so whenever they go across the border, they're returning back. Are they returning on the right direction? Seems like. Maybe not, right? Yeah. So let me address one more thing there. So when you go out of the screen, let's reset the z-axis to 0. In that case, here we'll come back on the right direction. So let's go back, and I think I'm checking the boundary in my scene again. I think that's what I do here. Let me check where, yes, there it is. So these are the two places I'm checking my boundaries. So let me put my z equals 0 again. So they will rotate into right angle in that case, right? And this one also for the other end of the wall. I'm setting this one to 0. Right, so now if they go and then what is this? Rotate z of my enemies. Okay, so this is I'm supposed to put there. Otherwise, it doesn't know what is this rotate is, right? So I had to do this one with the dot, right, and then this one with the dot as well. So this is a dot here, right? And compile and run. And then if I hit them, yeah, they're going like that. Hit them a little faster and then coming back, standing up. So it's good. Right now, yeah, the collision is there. You see that? That's the way it works for me now. So there's a collision and coming back. Yes. Right. So if you want to check the radial collision, which is the second type, only thing is I had to pass the values. Instead of I'm using this one, I can use the radial. So let's comment this out and check the radial works for me, right? So I'm going to copy this. in the radial collision, only thing I had to consider there is the value of my radius, right? What I'm going to give there as my the radius values. Okay, so that is one thing that I had to consider here. I mean, the concern how big it is going to be. So that is, let's say, instead of linear collision, I'm going to put is radial, right? So this is that, but I had to give a lot of values here. The first one is x position and the y position of the enemy, right? So okay, let's say the players x position and then players y position, right? And then my enemy's x position, and then again ENMS and I and dot y position. Alright, so let's assume the enemy has a very little small one, and my player also having a small radius. So if it is cross these little two circles, it's going to be collision. That's what I'm going to test here. Let's see what happens when I do this. Okay, so that is the radial collision, and compile it. Alright, so now if I hit, yeah, it works too, right? See, they're rotating. So in that case, I'm checking the radial, which is even you jump up over me, if there is a collision, this works for that too. So that is the radial collision, right? So now, right, one more thing I want to address here is I want to make them move the other way too, right? So this one is not working good. So only one direction is moving right now. What about the other direction? Well, I can put another action on that too, right? Yeah. So let me address that just to make it balance out. So this is one collision. In that case, I want to check the other collision, and then so how do I do that? Well, I can get the same values up to here. I can copy the same thing, but the movement direction has to be changed. So in that case, I have to apply something else. But the radial collision, the collision will be the same in that case. But which direction the enemy is moving now? So I would say it doesn't matter. In this case, they're coming from. Right. So yeah. So this is. But the x position is less than y position, so the player position. Oh, I'm sorry. This has to be other way around. So it is here, right? And then I'm checking the other way. But if it is a linear collision, it doesn't matter which direction. But if it is a circular collision, you have to check. I did not notice that. Maybe there's a little defect in it. And the action, this case, is going to be 1, right? Okay, so then I'm checking the radial collision, which is the same thing. And all right, so if you do it the other way, the people has to go the other way. So action 3, I did not implement action 3 yet. So let's go ahead and do that. What is the action 3 for my enemy, right? So this is the action 2. Let's have a copy of that and do some tweaks to move them the other way around, from here to break, of course, and copy that. Going to have my action 3. Alright, so let's go ahead and change this guy to 3. Okay, so what I'm going to do here, what are the changes I had to do? On the action 3, I do the 60 seconds and then all that, and then yeah, the rotations will be good, and where do I move? Okay, so I move to the positive direction, of course. So they will move the other way, right? And what else I have to do here? Well, let's run that and see if they're moving to the other side, right? Okay, so right, so if I hit this way, yeah, they're rotating. I will put the another rotation. I mean the direction of the rotation. Yeah, I want to rotate them the other way around. So in this case, the Z rotation is only anti-clockwise when I hit both sides, right? So let's change that a little. That means I want to do in action 3, rotate the other way around. So it is minus here. And see that rotation to the other one, right? So that is, let's see. Right, now that rotation that way, this rotation is this way. Right, yeah. Okay, so it's good. All right. So right, that rotation, okay, so the rotation is fine, but it is not feeling good, you know. It's just that's now our collision works, and the action that we applied works, but let's have better ones, right? Let's make them going on the projectile. So I did not address the projectile. Some people might think it's helpful there, help for their midterm as well. So let me talk about that a little and see whether we can implement something related to that. Okay, so the projectiles are something which is if you have some ball or whatever it is, right? If you throw it in an angle direction like this, it will go and fall like this, right? So how do I know what direction and how it moves? Well, the best way to do is break this into two vectors, right? So this is v, the vertex, I mean the velocity, and this direction is v2, right? This is the direction. But if I call this v0, obviously, and take this angle theta, right? So that is the direction and the velocity when it starts. So I'm asking how do I define this to x component and the y component, right? So the x component is usually given you by v0 cosine theta. And for the upward part, which is whenever it's going upward, obviously the gravity will work downward, right? So in that case, usually this vector is going to give you by the equation which is I think, as I remember, vt, right, sine, no, v sine theta minus gt squared divided by 2. So this is the equation, as I remember. Yes, I think it is the equation. Yeah, so yeah, if I use this equation to come up with how to do the projectile. Actually, I need the t here. Right, so it is this. It has to be like that, right? So right, so it is one way it is just v cosine theta, the other way v sine theta t minus gt squared, gt squared divided by 2, right? So this is x value and this is the y value. So if I apply that to this, it should go on a projectile motion. So what I'm going to do is implement this one to my action and see whether that works, right? So let's see, action 2. Let's take action 2 and apply that and see whether that helps me to implement. Okay, I mean it helped me to move things. Right, so the action 2, that's what I'm going to take care by this equation. And all right, so I need few of the things, which is angle, velocity, time, and yeah, that's enough. So let's go ahead and create those variables here. Let me create something called all floats, right? Yeah, all floats. Angle, let's call it theta, and velocity, velo, and that's how we already knows what it is, and t, right? And what else I need? Yeah, that's all. That will do. Right, let's think about something else if I need that. Okay, so comment out, so you know the angle. I need angle, not angel, angle, ups, angle is right. Okay, so the angle and velocity, velocity and time. So that's what I have here. Okay, so let's go ahead and initialize these in my constructor, right? So so go to enemies and go up here. So the things I need is these. Okay, the theta, let's have just have this fixed number here, like 30 degrees, maybe 35. Yeah, 35 degrees. And the velocity, oh, I have to have the radiant value, right? So let's have 30 radiant, right? So in that case I need obviously the pi. So let's define pi. Where do I do that? Define pi in here, in h is better place, right? So enemy.h and define pi. So oh well, right here. So let's have pound sign define pi. What is the pi value? 1 minute. The pi value is what? Pi value is 3.14 what? 3.14159. So it is 3.14159 is enough. Yeah, that's enough. So that is pi, and then right, so we're gonna apply that to my here. So the pi divided by 180 is my radiant value of that theta, right? Yes. And then the velocity, how much we gonna apply for the velocity? Well, let's have right, so the velocity will be 35 maybe here. Let's have 35 degrees or 35 degrees, 35 meters per hour or something like that. Meters per second, obviously, and the t value is set to 0, obviously, because one more thing, I like to have gravity in this case. Let's define gravity in my enemy.h. so the gravity I'm going to define here, define gravity 9.81, right? So that's what the standard value. Yeah, so that's something else, something I'm going to use. So I don't have to define it here anywhere, so I'm going to straight apply the gravity into my equations, right? So it's something else. Right, so now I'm going to apply some movements, but I had to scale it down for sure, because my screen is not that big. I mean, my viewport is not that big, right? It's a very small viewport. But anyway, we'll leave the rotations. Well, I'm just having a one angle for each one. If I put a plus here, probably they will do rotations in a different they will do the different actions, the rotations, right? Yeah, so I put there plus and take off this minus and put it here. It will be fun, right? So let's have that there. So I will make the rotation happens as well. Right, and okay, so all right, so maybe I had to add this movement here to a very small number, because I'm going to have some x position movements here as well. So I'm going to modify my x position, y position. That's what I'm going to do. But I cannot assign x position, y position, because if I assign it, it won't start action on where it is right now. So in that case, I had to add some action. So x position. Right, I'm going to add some action, maybe negative equals, right? Right, so what I said about the movement on x is, let me write it down so we won't forget. So my movement on my x position is going to be this cosine theta. So it is very easy one, right? For my y position, it will be v t sine theta minus half gt squared, right? So that's what I have. Right, so this is what I'm going to implement there. So let me have that. Okay, so I will scale it down if it is too big, but anyway, so this is going to be v velocity, right, multiplied by cosine or the t cosine. So oh yeah, vt, actually here you have to have the t as well. I forgot that. So vt anyway, right, vt, so vt is right now is 0, so I had to change that to cosine cosine theta, right, theta, right. That's what I have there, right. Why is it not coming up? Oh, I did not save all, so now it will. All right, so yeah, so that is the cosine value. Maybe the x position is too big, so let me have very small one like this much. Right. Yeah, so that's a good one. We'll look at that. I'm just assuming that will be the good value, because as I recall before, yeah. Right. So then the y position, obviously you have to add something. Why I'm dividing it by 1500? Well, I just assume the g is 9.81, so that is 10 times big, right? And I have a very small one, which is 1 to 4. That is the scale that I'm going to move this. So, and then I'm going to change this occasionally 30 frames per second. So that is, actually I had to divide that by 100, right? And then because of the gravity, I put another 10. So that's why I just put 1500 right there, right? Because this one is running 30 frames a second, means it will increase very fast for this x position, right? So that's why I'm make him move very, very small values. So you can see, actually you can visually visualize the animation, obviously. Otherwise you won't see anything on the screen. So this is t multiplied by sine again theta, right? Theta, right. And obviously subtract from half means 0.5 multiplied by the gravity, right? I call it gravity, and t squared. So let's put t there again, t. Alright, so in this case it is a subtraction, and I like to make him go up a little bit more than the horizontal movement. So in that case, let's have jump them more up like that. Right, yes. So now I know the equations. I don't need this part, right? Okay, so good. So right, so yeah, this x movement and this x movement will be too much. So let me have this one very small. Right. Why I have two? Well, when the t hits 0, it won't work like that. So I have to address the t0 position case in here, right? When do I have to apply that? Well, this is a motion of a projectile. That means it will come back to the flow. Whenever it's hit the flow, I have to stop the reset my everything. So let's check whether he's hitting on the flow, right? So he go up and then come down, right? What I'm saying is, right? So when you're having this guy, this is my enemy, and this is my player. So the player hits him. He's going up and then down, right? And then whatever I want to do. So in this case, I have to make sure my t will be stopped right here, the timer, and restart my timer, right? So this is resetting my timer. Again, is go up, and yeah, whenever it hits somewhere here, I had to place him here. So that case, I had to put my y position again on this floor right here, right? So it is 0.2. Right, that is the position here, and yeah, so these two I had to do, right? And I had to increment my t. So when do I going to increment my t? From the heating position and all the way here, I'm going to increment t and then reset my t and again go back. So in this case, because of this, what I'm going to do is I'm going to say if, right, my y pass of my enemy, right, is greater than minus maybe 0.25, right? Yeah, a little bit up. Okay, if it's greater than this, then I would say my t plus equal, let's have 0.3 and see how it works, right? And else means it's going down, passing the ground. So in this case, I will reset my t to 0, right? And I reset my y position, y pass to the same place that I have before originally. So I put it that there. All right, so these are things I'm going to do when it comes to this is y pass, right? Okay, so yeah, so this will do, I think, right? And then you reset things. Let's see whether that works for me. And so this is only the projectile. It's very easy one, right? Let's see, my scale is working, so that's what I'm concerning, these values. Oops, there's an error here, which is okay. V is the velocity, cosine and sine. Cosine and sine is not declared. Well, I have the math.h, I guess. Let me see whether I have math.h on my enemies. I don't. So let me have that. Include. And need math math. Yeah, so I need that there, otherwise it will complain, obviously. Make it a little nice. There you go, and run it. Alright, so now it's running, it seems like. Right, and then right, so there you go. Now they're jumping up when you hit. That's nice. So this way it is rolling. Okay, some people are not right. So if I hit it this way, if it is in my range properly, right, and then they're jumping up. Oops, not in this direction, it seems like. So I had to address something on my left direction, maybe the right direction. Oh, it did not work like that. So let me see what's going on. Maybe I will do the collision range a little bigger. That will help. Right now my collision range is 0.05. Maybe I can set it to 1. So let's go to the collision. Well, the threshold value I have. Okay, so this is what I'm using. Maybe I have to take care of the radius here if I do this. So let's have yeah, so the radius value right here has to be bigger. So in that case it will take care. When it's reset back, it did not work right. So let me shift back to my one, which is my linear collision, and change this value. Maybe 0.5, maybe 0.1. Right, so that's what I'm going to use here. Just to do the adjustment like that, and see, that helps. So it is 0.1. It's very close right now. Okay, but it's a linear collision. That's what I'm going to apply instead of this. This is one where you have to play around with these two values right here, depending on your size of the object. In this one, it's just one linear. So okay, so I'm going to go to scene again and apply my linear one instead of this. So let's move it here. So, and I'm going to use my linear. These are radial, right? So let's compile and run. Right. So when you hit this way, it rotates. When you hit there, it's jump, right? Okay. So this way it rotates. This way it jumps. All right, good. So yeah, this look fun. You're playing with it. Oops, I have this thing. Let's remove that. Right. Okay. So right, and then right there you go. So in this way I can hit like that, or bumping up and then going that way. You can see now there's a problem. What is the problem? They are going off on the y value, so that's why my radial didn't work for the second time. So right now they're in a top high value on the radial, right? I mean the y value is changing. So how can I fix that? Well, one thing you can do, when it's hit the boundary, they're returning back, right? When they're turning back, you had to reset their y position. So we can do that. We can fix that bug right here. When they're hitting the wall, make sure the enemy's y position. Yeah, so the y position is 0.02, right? So copy that, paste it here. This is where I'm doing my y position. So y position, and set that to negative 0.2, right? And then here as well, the y position, right, and then it will be equal to negative 0.2, right? So that means whenever I hit the wall on the side, the boundary on the side, Well, he should take care of that by then. So let's see. Right. Okay, now they're in the floor. When I hit this way, they're jumping up. Okay, they're moving. Right, they're coming back on the right floor. Right. So okay, so there you go. But they're bundling up. Oh. Right. So now their rotation is nice. Right. So if I hit this way, yeah, and then going that way. Right. Okay. Right, so this called a lesson number 10, right? And yeah, you can see their placements is changing each time when they do happening. So it's all random, right? Okay. Right, so this is collision and the projectile. So this will be easy for you to do the midterm, but I like you to do your own code, except don't copy mine, right? So that is this is only for the understanding purposes, and use your own creativity and apply things better, right? Okay, so I'll see you on another lecture.